Hello? Cześć! Jestem Lumir. And this is only one meaningful sentence I know in Polish. So, sorry, but I will continue in English. I think that it will be better for most of us. So, while we are here, in this kind of long presentation, you will see 3 slots from engineers, not any buzzwords, not any bullshit, not any hiring stuff, just the 3 slots from engineers describing what we are actually working on in Red Hat. How many of you know Red Hat? Almost all of you. Perfect. How many of you know that we are actually open organization? A lot of you as well. I will briefly describe what does it mean open organization. Open organization means that not just code we are open to share on GitHub and other platforms, but also ideas, also thoughts, and also some processes, guidelines, and stuff. So I will show some examples in my part of presentation. This is the 3 slots where we try to briefly describe what we are working on. First one is mine, and then you can look for my colleagues. So, but the most important thing is that this will be only a brief description of what we are working on. If you have any kind of question, don't forget to go to booth and ask, or find us if you want to ask us directly. Find us and ask. We are really open, not just open organization, but really open people, and we will like to share basically anything which is not confidential. So I will talk about what does it mean to work in Python maintenance for Red Hat, because I am a member of Python maintenance team, which basically means that I'm working as a Python maintainer, not just for Red Hat, but also for Fedora. As you can see here, I'm a proud Fedora user and maintainer. So what does it mean? In Python maintenance team, the main responsibilities are keep everything up to date and stable, which is not that easy as it may sound, because we have to take care about products in really, really old systems, which makes it really hard. But also we are not just people who are keeping things stable, but we also have to move things forward and implement new stuff and adapt new technologies, because Python is really faster growing and changing environment. So we have to stay up to date and also implement new stuff, because what we implement now we will have to support for a long time. Also, the big part of my job is, particularly my job, is work with communities. I was working in Python community for a long time, even before I was hired to Red Hat, but now it's allowed to me to continue work with and for communities, and actually I can get part of my work time working on, you probably know that I'm a main organizer of Python CZ, I'm a teacher of PyMinis and organizer of meetups. We will see later in more detail. We are also ready, and we do it really often. We are helping upstream projects, a lot of them and a big one, we will see also later. And we are also working on Python itself, because this is the thing we are using, all of us, in Red Hat, Rail, Fedora, and all products. What does it mean to keep everything up to date and stable? Basically, the most crucial thing is stability. You know, if you can keep Python interpreter and all Python ecosystem stable to customer, that's good, because nobody has to touch their code base, because it's working all the time, all support long. But the next really important thing is security, maybe more important than stability for some people. But still, if you want to fix some security bug, you can, but you have to be aware of stability, and at the end, it's profit. When you can keep these 2 points in a game, then the profit will come automatically, of course. But keeping everything stable and up to date and with all security fixes, etc., may sound not that interesting, because you can just, update things, right? When Python has some security flaw, just update to the newest version and everything it's fine. It is, that's true, but if you see the portfolio of products where we ship Python and different versions of Python with different long support, then it makes it really, really harder. For example, in Fedora, we are shipping all supported versions of Python, which makes Fedora actually a good distribution for Python developers because you can test your Python code with a lot of Python interpreters, basically all available and supported versions. Then we have CentOS, which is kind of form of Rail, also open source project. I think that you know CentOS. We have also the beta versions of interpreters. As I said, if you want to make things happen sooner than later, and if you want to move things forward, we have to adapt also beta versions of Python. So make Python 3.8 stable enough to work to customers and users, in Fedora case, who wants to check their projects against Python 3.8, which is not released yet. Rail, Red Hat Enterprise Linux, another huge portfolio of products where we ship Python in the different versions for different long support. The whole ecosystem of Python, I mean, we are not taking care just about Python interpreter itself, but also about ecosystem and packages we are shipping with Python. And also Docker images, software collections, a lot of different ways how to ship Python and Python packages and ecosystem itself to customers and users in case of Fedora on CentOS. So this was the part how to make things stable and with all security fixes for all the products, which makes it really hard. But on the other hand, we are not just all nerds in the cave fixing all CVEs and vulnerabilities to make things secure, but we are also moving things forward. We need to, because what we develop now, we will have to support it for a long time, so our solutions have to be good. As I said before, in Fedora, we are really moving things forward because we have a lot of Python interpreters, basically all supported versions by upstream. It's packaged in Fedora, you can use them. But also we have more than 3,000 Python packages. Of course, Python maintainers in Red Hat don't take care about all of them because Fedora has a lot of volunteers and maintainers from other companies or just volunteers from community. But 3,000 Python packages is a lot. And if you want to develop something new, I mean, some change in the Python ecosystem itself, you have to do it in 3,000 packages as well, and it might be hard. So that's another big part of my daily job, on our daily job in Python maintenance. The huge project we are doing right now, and we are facing a lot of troubles with it, is Python 2 removal. We are trying to move Fedora forward to Python 3 only distribution. So right now we are slowly removing all pieces of Python 2 software, and it's sometimes it's simpler, sometimes it's not. Depends on how old are the maintainer. And I think that there will be a huge fight about Python 2. That's a thing when you are working for a company, but basically working on an open source project. So you have to be really kind, you have to be polite, and you have to be sure that you are also keeping community around the project, not just I am a Red Hatter, I will pay for it and I will do it. That doesn't work like that. If you want to check our progress in Fedora, you can. We have a special tool called portingdb where you can see how this effort is evolving when we are removing Python 2 packages, and a lot of packages are actually Python 3 compatible, and a lot of them has Python 3 only. So that's a huge success in 2 years. As I said before, you can use part of my job time to work with communities. I'm a teacher of PyLadies from 2016. I am a head organizer of PyCon CZ for this year and next year. You will learn about it more in lightning talks. And I'm also a Pivo Meetups organizer in Ostrava from 2014, I would say. And this is all not just supported by Red Hat, but actually supported by Red Hat, because my manager is a very wise man, and he told me, okay, if you can do it together with your job, then you can use the part of your job time organizing Python CZ. And if I can summarize it, this year it was many months, I would say, I can spend with communities, because Red Hat is open organization, and Red Hat knows that it's not just about software, but it's also about people. So yeah, we are really highly allowed to work with communities and on communities project as well as just the software, right? Red Hat uses a lot of upstream projects, and when I say uses, I don't mean just uses as a component in some pipelines and builds software stacks, etc., etc. But I also mean that we are shipping those projects to our customers. So, and we are using them really, really much. So, when you find a bug, it's easy to fix it. It's open source projects. All of you can do that, right? But what if you want to do something kind of different? The good example is Samba. Samba was my project for maybe 2 years, because my friend, Dmitrii, probably know Peter, told me we need to port Samba to Python 3 compatible form, and it will be hard. But not just hard because for code, but it was hard because it will be hard because of people. There are people who don't want to accept Python 3 at all. So please take care about it. And I was invited to the community of Samba. I was helping Samba developers to make the code base Python 3 compatible, and it took a lot of time, but it finally happened, and the new version of Samba is Python 3 compatible for all of you. Just because Red Hat did it and dedicated person to help upstream projects. And as I said before, I had to be very kind because it's open source and Red Hat has no power there. But it's not just about old Samba where Python were added just to get more developers, because Samba is mainly in C, but also the big projects like Ansible, where there were a lot of problems with porting to Python 3, PyTest, and a lot of other projects. We are basically working with open source on open source. Our code, we are publishing it as open source as much as possible, and we are also contributing to open source projects. So maybe you know me as Lumir, but on GitHub I have some nickname, so you can find me there, and my contributions will look like I'm doing nothing else than contributing to open source project, and it's basically true because it's my job. But it's not all. We are also working on improving Python itself, because we are using Python really heavily in Python maintenance team, and we are using it on different platforms, different scenarios. Then it makes sense to, when we find something interesting, some new feature, some bug fix, etc., we can also send it to upstream. So we are sending patches to Python, especially CPython itself. We are writing PEPs. You can find multiple PEPs, which is Python enhancement proposal, written by members of my team. And we are also contributing to community around Python or CPython itself, Python Software Foundation, etc. My teammates, Peter Victoria and Victor Stinan, unfortunately cannot be here with us because they are on Python core developers sprint in London right now. So yes, in our team we are also spending our free time working on Python during the weekend, because in our point of view it makes sense. And that's the end of my part. If you want to know anything else, if you want to ask questions about Python in any of our products, if you want to, how is it to work for Red Hat, then ask me. And I forgot to mention that I'm full-time remotee, so I can provide also some insight about how is it to work as a remotee. Thank you very much.
Hello everyone, my name is Dmitrii Misharov, and I will talk about how we develop functional tests using Python, how we do it in Red Hat. So, I'm a quality engineer, as I said, I'm in Red Hat for an office. I'm a full-time employee. I'm using Python as my my main programming language. It's my daily routine. And nowadays, I'm working on test automation for CloudForms. So let's think about how we usually develop a functional test for web applications. So for first, like straightforward approach, we create a simple monolithic test framework that will contain, for example, some tests, usually PyTest, some Selenium Python buildings, REST API client, configuration system, and some custom abstractions around your web application. So that's what we do, like in our previous project. We created monolithic test framework, and it looks contribution looks like that. So we have the framework. It has some parts divided by subsystems. Each contributor was responsible for each subsystem, and everybody contribute to one monolithic repo. So that can be done, but there are some problems with that. One of that is quite hard to maintain. For example, if you PR or code break something and can be break everything, whole framework, whole SU. And another problem that it's designed only for one web application. So if you want to move, like to try to transfer your code to another web application, it will be quite difficult to do. And that's why we decided to create something which we can use for like more broad, more common way. So that's how we came to Taranto. It's our framework for frameworks. So it has some concepts like application object, entity objects, implementations, widgets, navigation, and plugins. I will tell about this in details further, but we will see firstly how it looks like, how does it look contribution model in the case if we have plugins in our list. So we have core, which will contain all required objects and classes for your test suite, and subsystems will be plugins and not part of the framework. That will be easier to maintain, and release cycle will be independent. So for us, we found that this approach will be more productive and secure, I would say, stable. So let's go into details. What are concepts we introduced in our framework? So first of all, we should start from application object. So what is application object? So it's a basic building block that holds whole information about your web application. And so it will be your main entry point where you can start to create your framework. So basically, just a class where you can define some URL, schema, and other useful information which you can put into this class. In lower level, there are entities, and this object that represents the parts of your web testing web application. For example, most of rich web applications have some role-based access model, and there are some users in this model. So we can represent this user as a Python object, and this object could have some attributes and methods which will do some actions which you can do via a web application, and we can implement these actions via Python methods. Next thing, it will be widgets or components in another terminology. So we're going down to lower level. So we now represent UI controller methods. So components. For example, you have some buttons or drop downs, and to interact with these buttons and these elements, we created a special library called Widgetastic. which allows you to interact with these elements using Python objects. And we created several libraries around most popular usable popular libraries of widget elements like Twitter Bootstrap, or we have our own component library Buttonfly. We also created a set of components for this library as well. So basically you can just instantiate that element via Python code and use it in your entity, for example, and in your test. And we also define concepts of use. These are like set of this widget. Like if you get some, for example, page with some navigation bar which will not change, across the navigation, you can define this as a view and inherit, in the code across different, places. So basically, for example, we have this base page class which defines your two text inputs and one button, and you can interact with this class and widgets. We are again using Python in different classes and methods. And one thing, additional thing which we can use is navigation. So we created another library called Navmazing, which can be used to define the steps, how to navigate across your web application. So we just define the steps how to get to some certain destination of your web application. Can it be some admin part or some details of some end user, for example, account, and so on. And that's how it would look like web UI test called stack. So it starts from application, and then the application can instantiate entity. Entity contains views. Views contains widgets, and the lowest level will be Selenium. So we have a lot of abstractions, to hide this complexity of using Selenium, and for one specific reason, and I explained further why we needed to do that. So that's how we like, the usual graph test, like simple create, read, update, delete test. So let's imagine we have some system entity, some dashboard or admin page which allows you splitting the button, create some system. And using our framework, you can just define that simple create test with some small amount of code, and we will just create this, check this exists, change some host name or some another attribute, and we can also delete this and check this exists or not. So all these attributes and methods are should be implemented, of course. And next question can be REST. So what if we want to test REST API as well? Because this was only about web UI, but as a test automation, we also need to test not only web UI but REST API as well. And we don't want to create additional tests like test CRUD REST API. We want to use the same code for the same purposes, like just to test that entity is created and it exists or it can be updated. So there's another part of our iterative framework. It's Sentaku, another library. It allows objects to dynamically choose their implementation. So we have one implementation, it's a web UI, but we also want to test REST API. So using PyTest, we can define several, implementation using parameterization. So web UI, REST API, and create application with different context of web UI or REST API, and provide this context to our test. And the code will not change. So that's the advantage of our approach. So you can use your test your code and don't change the code of the test. And there's also another advantage that code of your entities of your framework can be consumed and used by other teams, and they don't need to invent, for example, their own implementation. So the whole idea of that Toreta is providing you an ecosystem of Python libraries, which allows you to create Python API around the testing web application. So creating this Python API, you can create your tests and provide this Python API in other teams or collaborators. And you can find references here, and that's it. Thanks.
Okay, does it work? Probably. Okay. My colleagues talk in English, so I will talk in English as well. And I would like to tell you something about day-to-day life of the most common software engineer there in Red Hat. And as an example, I will use our product, Red Hat Platform. I'll tell you what it is, how does it work, and some challenges we met, some problems we solved. Red Hat Cloud Platform is a new stuff. It's something which was called Insights formerly, and it's basically a thing you get for free if you buy RHEL, Red Hat Enterprise Linux, and it's a client that gathers some configuration and similar data from your system, and then in the cloud online it's parsed by some rules, and the result is a list of vulnerabilities or some compliance issues, security issues and stuff, which you can remediate with Ansible and stuff like that. And one part of this is an inventory, which you can see here. And it's, as you can see, it's a very simple application. It's just a list of known hosts, and that's pretty much it. Like it's a single source of truth for other applications, so they know what virtual machines and real machines are out there. And it offers some basic operations like show the whole system profile and ability to delete the host, and that's pretty much it. Okay, this whole stuff is deployed in OpenShift, which is a superset of Kubernetes. We use the Flask framework with something called connection, which actually translates an open API document to Flask operations, which means that you don't have to define routes or validate your input or output. And it's compiled by something called source to image to be deployed as a Docker image to OpenShift. And in backend we use Kafka because there are many host records, and we need to pass information about them as quickly as possible, and also in peak times when there are like thousands of hosts added at one time, so Kafka helps us handle that. And by now we also are starting using it for an event-driven API or event-driven interface, which is one of the challenges. Okay, so I just wanted to give you a quick look into some problems which are sometimes funny because it looks like everything is pretty obvious from the start, but it wasn't. Like, for example, even here at Red Hat, we were pretty naive in the sense of what an API for such a simple service should look like. It looks like that something like CRUD operations is enough, like create and delete, and okay, why not? And then some problems started to appear, and well, it was not 100% predicted, because we saw that if you add a host manually, you add one host or 10 hosts, at a time because your machines report information about new hosts. But sometimes these data are aggregated somewhere by another service, and then back you have to process thousands of new records at the same time. And the single API, which was intended for public or UI use, was not efficient. So, hey, we need to split the interface into an internal and external one. And then we found out that REST is not a good solution for this because parsing the HTTP request is slow and inefficient, and still it has some limitation. So that led us to Kafka and to an event-driven APIs where we just read the message about there is a new host and hey, save it. So, okay, that was one of the nice challenges. And so before that, I didn't even know that there is something like Kafka, and today I work with it every day. Deduplication is also an interesting thing because it sounds easy, like you have a record which you want to insert into a table, and it has some data, and some of the data can be like keys, and if you want to insert something with the same key, it's the same host, and you don't save it. Oh, well, not. Because virtual machines, or the real machines, have a lot of information stored about them, and some of them are more or less canonical, some of them are volatile, like the MAC address is pretty much fixed, like the MAC address of your network interface, but something like IP address is not that much. And you can also do stuff like you have your host there in AWS or somewhere, and you just create 100 of clones of it, and then you have 100 new machines, and they have exactly the same facts. Pretty much every fact is just the same. And you have to detect it, that you have new hosts and not just reported the same one again. And it's not very well solvable by assigning your own ID, because you can unregister the machine, register it again, and still you have to somehow match it to the record you already have. So again, it was pretty interesting stuff. And one thing we need to think out was how to do this deduplication in a database table, actually Postgres database, which has like millions of rows, and you need to compare some of the fields with some logic, and to do it efficiently. Like with every update, you need to do this to figure out, hey, is this a new host, or is it just an update coming for an existing one? And that's where a hybrid database, which Postgres actually is, comes into play, because you can have a relation table, but with some JSON fields which can be somehow operated upon with some logic, like matching and stuff. And that was also pretty interesting, because we essentially have no SQL approach to a relational database. Also fun. Okay, another fun stuff for every programmer out there, it's race conditions, as always. What happens if you have a new host? This host reports something and it saves itself into our database. Then it pushes some of its data to another service, which after some parsing and stuff reports back to the inventory. So it's just one host sent to the inventory from two sources, because one is direct, one is from some parsing by other services. And in the meantime, before these two things happen, the user comes and wants to delete the host. So the user deletes it, and then the new information comes for this host, and hey, was it the same host and which was deleted, and we don't want to update it, or is it just the host has been recreated and we want to create it again? Cool stuff. So, and also, it sometimes happens that more services want to do different operations on the same host, and if one of them is deleted, it's always funny. And that's also when Kafka and its event-based, event-driven interface comes into play, because then you are pretty sure what is the order of the commands or of the events that happen. But again, you have to somehow report the result, and somehow you need to track the ID of the request and stuff. And hey, one more challenge again for such a simple application. And the last thing was data decentralization, which is a way we took. We don't want to store every single piece of data in one database. We made it that the inventory has some basic information about the host, but about information about the insights rules are in the insights database. The information about the remediations and Ansible playbooks are there. And then you find out that you need somehow to aggregate this data and to filter and search and do something with all of the data which you don't want to have in a single place for various reasons. And so another interesting technologies and approaches appear, and we're going to have a service which gathers the data updates directly from Postgres and applying these database patches to a different database, which is going to aggregate the facts that are needed either for the UI or for the public-facing API. And hey, it's something called Elysium and stuff like that. And hey, I never heard about it, and it looks like we are going again to use it every day. So another challenge, another fun stuff. Okay, I know this was pretty abstract, but I wanted to show you that pretty mundane things can come up every day. And even though working in Python doesn't sound very challenging, it is. Even if it's a one simple application with a list of something as simple as virtual machines, it's fun. It's every day there is something new to learn, and I would recommend it to anybody. So that's it. Thank you.
Okay, and now it's time for questions. As I said before, you can reach to us and, of course, ask us directly if you want to. But we have some questions, and I try to find who is this for. Is there a how to walkthrough tutorial or recommended example code repository showing how to use Toretto for testing a specific moderate and complex application? I think it's for you.
Yes. Thanks for the questions. Yeah, there is a tutorial and recommended example code. Yeah, you can ask me. This like test repository is not in the slide, but I have this. You can go to me to the booth, and I will provide this. And I would also mention that Toretto is in development yet, but you can use it and some parts of that. And yes, you can find some tutorial as well. Yeah.
I think you can ask the third one as well.
Yes, Toretto is open source, of course.
Of course. It's a pilot like it. Okay, do you work only with Python? What other languages do you use in Red Hat on daily basis? From Python maintenance team, we are using Python as a main language, Bash for some scripting, and if you want to work also on C Python level, then you need to know C, but it's not mandatory. So yeah, basically everything we wrote is in Python. And I don't have any data for that, but I think that most of tools around Red Hat Enterprise Linux, Red Hat in general, and Fedora as well, are written in Python. And the next one, how many Python maintainers is there in Red Hat? My team consists of 8 people, I would say. 4 or 5 located in Brno office, and the rest are remotes, including me. But as I said, a lot of products and tools around are also written in Python, so it's not just Python maintainers using Python, but the whole Red Hat do. Yeah, on the basic level, how Toretto differs from Selenium.
Yeah, Toretto doesn't differ from Selenium because it uses Selenium, because it's wrapper around Selenium, but the purpose of that is to to not use it low level like calls of Selenium, but provide some high level API to create your testing framework. Of course, you can use Selenium for simple application, one-page application. There it doesn't make so much sense. But if you have a lot of pages, some navigation, heavy navigation, using Selenium, just throw Selenium will be helpful. You will find it very quickly. So that is an approach to have this low-level Selenium stuff under a high-level API.
Great. Is Red Hat contributing to OpenGDK or adopt OpenGDK? I don't know if any of you have answer for that, but OpenGDK, as far as I know, is on GitHub, so you can try to take a look in contributors, because most of Red Hatters are proud Red Hatters, so you will very likely find a photo with Federas or mention of Red Hat in the user profile. But then, because it's all open source, you will never know whether the Red Hatter do this in a job or in the free time, just a volunteer contribution. So, sorry, I don't know, but we can find it together on GitHub. Do you use only Red Hat Cloud or also another one like AWS or, for example? That's another question I don't have direct answer for.
For me. As you can see, this is for a slightly different product, but from the same family. You can control your hybrid cloud, and that means that your machines which are managing can be pretty much anywhere, like in Red Hat Cloud, in OpenStack, in AWS, in Azure, and even on your own premise. So if you have your own data center with your own machines, you can still manage that with Red Hat Cloud.
Thank you for the answer. I will add some information for it. It's that we have our own cloud, but we are also developing products for another clouds, cloud provider as well. So we have to at least test it on other providers. Do you wear fancy red hats during work? No. The fact is that this one is not mine. I let mine fedora on the sun for a while, and now it's pink, and I don't want to wear a pink hat. So no, the truth is no. It's not comfortable. Did you work in different time zone? If so, how did you manage that? Yes, it happens quite often in Red Hat, and the only thing you have to take care of is carefully scheduling meeting, so it won't happen in the middle of the night for somebody. But that's all. For example, my colleague from Python Maintenance usually travel to USA, to Boston, and then we just need to schedule meeting properly. That's all. We are communicate basically on emails on IRC, so it's not a big problem. If you have specific question for this one, just ask us later. If that's all, thank you very much.